Okay, so today we're going to learn how to find the shortcuts of graphing polynomials. And so the first thing is, this thing is in factored form, and if you get a polynomial that is not in factored form, you should put it in factored form. So we've spent a lot of time getting things in factored form, so this is its factored form, and so we're going to use this to try to find all the information. The first thing we want to do is find the zeros of the function. So that would be 0, this would be 3, this would be -5, and this would be -1. Now we're going to put that on a graph. Just make little marks at these points. Okay, so we have the marks for these points. And the first thing we need to do for our shortcuts is to find what it's going to do out here in this area. If it's going to either go down or it's going to go up, like we need to know if it's in the positive region or the negative region. To do this, we're going to pick a very, very big negative number, maybe -1,000. Well, if you plug -1,000 in for x, you get a negative. If I plug -1,000 and then I square it, it's going to be positive, so I'm going to get a positive. If I plug -1,000 and I add 5 to it, it's still negative, and then I cube that, it stays negative. And then if you plug -1,000 and add 1 to it, it stays negative. Well, a negative times a positive times a negative times a negative, that's going to be negative. So it starts down here. Now here's how the shortcuts work. These things all have degrees. And even if they're not listed, they still have degrees, and those degrees are just 1. We call that its multiplicity. So the multiplicity of this is 1, the multiplicity of this is 2, the multiplicity of this is 3, and the multiplicity of this is 1. The multiplicities of a function will tell you if it's going to bounce or if it's going to go through. It will bounce every time you have an even multiplicity. And it's going to go through every time you have an odd multiplicity. So when we look at our -5, it has an odd multiplicity, so this thing is actually going to go through. If you look at -1, which was this one, it's also going to go through. If you look at 0, since it was 1, it's going to go through. And then at 3, we finally have a multiplicity of 2, which is even. So this is going to hit that axis and bounce off of it or stay on the same side. So another way to see this bounce is, let's say, stay on the same side. And that would be our graph. As you can see, that's a lot faster than deciding the positives and negatives. The next thing that we need to be able to do is look at a graph and tell what its degree is. So, to be able to look at a graph and tell its degree, the first nice thing to do is, I want to know how many real roots the thing has. And roots are every time it crosses the x-axis. So this has 1, 2, 3 real roots. Now I'd like to know what degree the polynomial is. Now, there's a lot of times that it's equal to the number of real roots, but in this case it's not. Here's how you decide the degree of the polynomial. You are going to see the number of hills and valleys this thing has, or maxes and mins. So how I decide this is I create the number of maxes plus mins, and then I add 1. So this thing has 1, 2, 3, 4 maxes and mins, And if I did 4 plus 1, that's going to give me the degree of the polynomial. So this thing would be a degree 5. So the real roots are how many times it crosses this x-axis, and the degree of the polynomial is how many maxes and mins that we get, plus 1. The last thing that we'd like to be able to do is, given a graph that's not in factored form, we'd like to be able to put it into factored form if we can see the graph. So this is the graph over here on the right, and this is my function, and the issue with my function is it has 4 numbers, so I can't really factor it, which means I have to divide it. Well, I also didn't say, like, given a factor. So sometimes if you've been given a graph, you actually know the factor. The factor is this thing right here. It's where it crosses the x-axis. So your factor, so it'd be like if I said given x plus 1. Because there is my factor. There's where it's crossing the x-axis. So again, we'd use synthetic division for this thing. Carry down the 1, negative 1, 2, negative 2, 2, negative 2, 0. And we could see that in factored form, this would be x plus 1, and then x squared plus 2x plus 2. And the reason this one doesn't have any more real roots to it is because this thing doesn't cross the axis any more times. So this thing actually doesn't factor. So that would be my final answer in factored form. It actually has 2 imaginary roots, and you can see that this should be a degree 2 because we have 1 hiccup there and 1 hiccup, or degree 3 because 1 hiccup there, 1 hiccup there, and 2 max and mins plus 1 would be 3. So in these problems, make sure that you kind of combined everything that we've learned so far.